All right. Good morning and good afternoon to everyone. As you mentioned, I'm Chris Barr. I'm the Federal Program Manager for the Nuclear Science User Facility, or NSUF. Today, we are excited to share the NSUF component of this CINR FOA. Just a brief reminder, all information provided should be considered tentative pending the final release of the FOA. As mentioned by Drew previously, NSUF will have two topic areas in this FOA. First is the joint R&D and NSUF access, and the second is the NSUF access only. With that very brief introduction, I will now hand it over to Brendan Heydrich. Brendan is the NSUF director and will provide the presentation, which will include an overview of the NSUF and the NSUF components of this FOA.
Okay, excellent. Thank you, Chris. Yes, I'm Brendan Heydrich. I am the NSUF director. People that may be sort of out of touch with our internal workings might remember Rory Kennedy. He was the director for 9 years before this. Rory retired from the NSUF, but is still at Idaho National Laboratory as he works on a few other opportunities here. So the nuclear science user facilities, as we mentioned, we have got 4 topic areas in this. We definitely have a different portion of the CINR with a bunch of different requirements. So as Drew and others have already said, while we'll discuss the things here, the slides will be available following this webinar. Please, if you have any questions, reach out to NSUF or the NEP office as appropriate. Our contact information is on the last slide of this particular presentation. So moving on from that. The NSUF, the Nuclear Science User Facilities, is DOE's Office of Nuclear Energy's sole user facility. There are dozens across the rest of the Department of Energy, but we're focused on nuclear energy, advancing that and supporting our research community in that. Particularly, we're focused on irradiation effects on fuels and materials. So you'll see that in our topic areas, along with sensors and sensor materials. Beyond anything that sort of fits in that area should be appropriate. And you can go on our website, and I'll show you how to do that, and look and see past research projects that have been funded by NSUF, so you can get an idea if you have any particular questions about relevancy. We do 2 types of open competitive proposals, and for the most part, all the work that NSUF does is through an open competitive process. With the intention that it's all published. There's not proprietary information associated with this work. It's intended to accelerate the development and deployment of nuclear energy, so that's what's available for everyone. The Consolidated Innovative Nuclear Research, FOA, that's what we're here to talk about. We could do a variety of work. We provide access to these national lab and university and industrial capabilities to support this work. So the biggest projects that we do, a neutron irradiation, so a research or a test reactor irradiation, that can be the Advanced Test Reactor at INL, the High Flux Isotope Reactor at Oak Ridge, the TREAT Transient Testing, Fuel Safety Testing Facility here at INL, the MIT reactor, a variety of other research reactors that we have. These can be 7-year projects because it can take a year or more to get into the reactor, a couple of years of irradiation, some cooling time, and then maybe 3 years of post-irradiation examination characterization. So unlike almost all of the other areas in this FOA, these can be very long projects. So, and we'll help you plan that out. They can also be very expensive projects. I think Drew mentioned we have around $5 million planned for this next year. Depending on the budget, that could be more. This is one of our major activities. But the intention is that we would support any of these projects up to that very large amount. You could also do a post-irradiation examination only project, whether either you would supply your own irradiated materials or access our nuclear fuels materials library, and I'll talk about that in a bit. Those are smaller projects. You'll see everything else here we kind of talk about is with a 3-year time frame. There's a possibility you could only neutron irradiation only. We've certainly done that work either in TREAT, where the experiments are actively monitored, or sensor test, where there's no real need for post-irradiation examination. We have a variety of ion beam facilities that are available to do irradiations. gamma radiation, post-radiation examination. Any combination of these, in all of these, of course, can be tied to our high-performance computing resources. So if you can come up with a project that uses these resources, you need access to them, come and talk to NSUF about that. Just for your information, we also do what we call rapid turnaround experiments. We have usually 3 open calls a year for these much smaller projects. I won't spend any more time on them, but they are available on our website if you have any questions. Next slide, please. Thank you. So I mentioned we have capabilities here at Idaho National Laboratory and some other places. We actually have 18 partners across the U.S., national laboratories, universities, an industrial capability at the Westinghouse Churchill Labs. So we can fit your experiment, your project, to the right capabilities. There's no reason to put some material that's just completely novel and has no irradiation history directly into a high flux test reactor, when maybe either ion beams or a research reactor would be the better choice for this. And we'll help you make those decisions and write this plan. But we have everything that you see here, once again, all available on our website in more detail. We're adding partners, I say not constantly, but we're always open to adding partners that would offer our community unique or very hard to access capabilities. And you see in the gray box off to the right, we'll be looking to add the high energy X-ray microscope at the advanced photon source. It'll come online probably late calendar year 2024, but it would probably be available for this. If you're interested in using that, once again, reach out to us and let us know. I said all the capabilities, all the partner contacts are available on our website. Next slide, please. Thank you. I mentioned the nuclear fuels materials library, and for this we've got was it over 9,000. That's approximate number of specimens from either previous NSUF projects, other programmatic research projects, decommissioned power reactors, EBR2 or FFTF materials, harvested materials from, well, we're trying to get them from around the globe. So this is also available at our website. I'll point to that in one of the final slides. And you can access these materials through one of these competitive proposals, at certainly at no cost, once again, so that you might not have to do an irradiation test because the materials might already be irradiated. That has the benefit of reducing the cost, which the users don't necessarily care about directly, but what they do care about then is that we can award more projects, and you'll be able to get to doing characterization on these materials much more quickly, so you can get your data, get your publications more quickly. We have one person, a staff member, that is solely devoted to the fuels and materials library. So once again, any questions about it, please reach out to us. We'll make sure we get the right person in contact with you and get you help planning your experiment. Next slide, please. Nope, sorry, one more. Thank you. There we go. So I mentioned irradiation effects on fuels and materials, and this overly busy slide is really designed to just show all the areas where we've done some work. So obviously that's the irradiation effects is the core of our work, but that could be splinter off into advanced cladding, fuel development, welding and joining, including obviously welding and joining of difficult to handle materials, model validation. We've done work in collaboration with the NEAMS program to generate data to validate codes. Sensor development, we've had basically a wide variety, half a dozen large irradiation tests that were designed to test sensors or sensor materials anywhere from a very low TRL, really sort of testing a new type of material that might be used in a sensor or an instrumentation system, all the way up to we just recently completed a qualification test for a nuclear vendor. Advanced manufacturing, we got into that very early on. We've been doing that for basically a decade now. Irradiation tests, often the very first high fluence irradiation tests of new materials or new material methods. So if your interest falls into any of these areas, then it's probably a decent fit for an NSUF access proposal. Next slide, please. Thank you. So this just shows in the years since we've been involved in the CINR FOA, the awards that we've given sort of in these different large areas. You can see we've got good representation in every one of them. The off to the left is by the number of awards given, and then off to the right is by cost. So you can see maybe this, the fundamentals of reactor materials is almost a third of the number of awards, but a lower proportion of the value of the access. And that is almost entirely due to the fact that most of these were actually PI only, where we had either done the irradiation before, or like I said, harvested material from probably in many of these cases, the EBR2 reactor series of campaigns. Whereas some of these other tests, like sensor testing, that's almost all been actual irradiation tests. So once again, the user doesn't necessarily be concerned about the cost. It's probably more about the amount of time it takes them before they can actually start getting their information. Next slide, please. Thank you. So the specific topic areas for this, like as mentioned, we have 2 topic areas. They look generally identical in that we have fuels and materials with R&D support and sensors with R&D support, and then what we call access only. So NSUF 1, we're providing R&D funding for this, or R&D funding is being provided up to 7 years. Except those are really reserved for those big, long irradiation tests, up to $1 million of R&D support, and then access funding up to a limit of probably about $4 million. And I will say that is a big test. So that would also have to be a very, very well-reviewed test to award one proposal that would essentially eat up all of that funding. This is specifically support for irradiation, post-irradiation examination for these nuclear fuels and materials and or sensors. You'll notice that this bolded note here. The NSUF sections are generally not for development of materials. So if you are considering something, well, we think we have this new method that might be able to make this material, this really isn't the right topic area for you. What we're looking for is we've done that. You make the material, now you're concerned about its ability to stand up to neutron irradiation or ion irradiation if it's early enough. We want to do the irradiation testing for you, or alternatively, the post-irradiation examination of previously irradiated materials. And the challenge behind this is that we have test reactor schedules, other large facility schedules that will get you on. And if the development is far more challenging than expected, it could take multiple years to get there, which means we're sliding and we're taking up a spot in a test reactor that somebody else can't have because we've got a pending experiment for it. So the NSUF access is generally for materials that are essentially ready to be irradiated or can very shortly be ready to irradiate. And once again, if you have questions about that, reach out to us as soon as possible. Next slide, please. Thank you. Okay, so specifically sort of the same discussion. This joint access, you can have neutron irradiation and post-irradiation examination, all of the areas that we talked about before. And like I said, very importantly, combining high-performance computing. We're definitely excited about experiments that will couple with our advanced modeling and simulation capabilities here in NE. Do want to mention, you've already heard about the user agreement. This is an agreement between NSUF and the user, and will basically both solidify the final statement of work so that we both sides understand what we've agreed to, what your experiment needs, and what we're able to provide for that. And then the other big issue, once again, is any NSUF readiness. That's defined in the FOA, and it basically talks about the fact that, the materials you're going to test, you own them, they exist, you know how to make them, and they'll be ready for irradiation. Obviously, there's a few more items than that. Please look over it, and if you have questions, reach out to us. One thing that I did sort of neglect to mention, once you put in your letter of intent, which is required for the NSUF applications, the program office will very quickly assign you a technical lead. And that technical lead will help you navigate the NSUF work area. So we don't expect you to know how to design an irradiation test. We'll do that for you. We don't need you to write a project manager level schedule or budget for that. We'll do, for the access side, we'll do that for you. And this technically will help guide you through this. So once your application is in, I won't be able to answer questions for you anymore because I'm involved in the process, but your technical lead can. So if you have questions about, well, what does it mean for readiness? Is my material ready? Here's the state of it. You'll be able to talk to your technical lead and they'll be able to help you navigate this and help you to write the best NSUF proposal that we can put that you can put together with them. Okay, next slide, please. Okay, so specifically NSUF 1.1, this is the topic area that includes R&D funds and is focused on core instructional material development. So fundamental understanding of radiation effects, any of the nuclear material, nuclear energy fission associated materials should be good for this. We have done a lot of structural materials. We've done a lot of fuel work, but we also are doing an experiment right now looking at adhesives that would be used to attach sensors for advanced reactors and new applications that haven't existed before. And that experiment's actually going very well. You can see some of the areas that are discussed here. These are all typical. There may be something that we haven't included in here that is either novel or just maybe outside what we've been talking about before. Once again, please reach out to us. I expect if you fall in this general area that you will be relevant. Next slide, please. Thank you. So the second work scope that also includes R&D funds is the advanced materials for sensors. So this is specific area because obviously the advanced sensors and in-core instrumentation is vital to a lot of the advanced reactor system, well, current and advanced reactor systems, where the mode of operation may be very different. So we were involved in both sensors for power plants, for operating plants, but also sensors and instrumentation for test reactor and research reactor experiments, which basically live in a very different environment and require different sorts of testing to get there. So we have a topic area specifically for that. This is really focused on irradiation testing. Certainly, if you have a proposal, you can add post-irradiation examination following the irradiation test, but these areas don't have to include that if you can get all the information you need from monitoring the sensors during the irradiation. Okay, next slide, please. Thank you. So these areas will look very similar to what I just talked about. You can see there, specifically, there are no R&D funds provided here. The access funding level is still the same. This one is now open to not just universities, but also national laboratories and industry. We have the same requirements for readiness. We will also be asking for some indication of where your funding for the PI, for any students, if that's included, is coming from. And that's really sort of still falls under this NSUF readiness, is just as a matter of due diligence, the program office wants to ensure that you do actually have funding, because once we start down the road of building these projects, we don't want to be a situation where the PI was actually unable to secure enough funding for them to do the work. Then we'd have to cancel the project, and that would be unfortunate and would have taken the place of somebody else's project. So we will be asking for that as well. Next slide, please. Thank you. So this is all very similar to what you've seen before. Once again, now this one doesn't have the R&D funding, so you'll see an additional restriction that we don't fund traveling salaries or other user costs. Those have to be in this area, has to be taken care of by the applicant themselves. Next slide, please. Okay, so this, like I said, this looks like 1.1. The next one, please. Thank you. And this one also looks like 2.2. So you can look at the draft topic areas, and then of course reference the actual FOA when it comes out to make sure that the areas are still the same. Next one, please. Okay, thank you. I did mention, in addition to other capabilities, NSUF supports INL's High Performance Computing Center. You can see the machines that are available here. Any CINR awardee can get access to the HPC for their project, and that's done through the Nuclear Computational Resource Center. You can see the website at the bottom. And once again, with all of the NSUF projects, it's not just access to the facilities, it's also access to the expertise. So you don't have to know how to run the HPC or how you would even necessarily utilize it. As long as you've got an application, we'll help to provide you the expertise to use these resources. Okay, next slide, please. So on the flip side of it, we do have some cautions that we want to make sure. Because NSUF is often in a cross-cutting area, we want to make sure that we're not either duplicating our own work. We've done just over 700 projects now in the 16 years we've been open, but also that we're not duplicating work that another program is doing. So we will ask about that. With the first sort of line of defense is that the PI, the applicants, don't propose something that's already been done. So we give you some resources to look that up. If you think you might be treading in this area, please be very clear in your pre-application or your letter of intent why this is not the case, because we'll be looking at it. And like I said, we have, other than the technical lead, we have some limited, very limited ability to ask any questions. So we may end up making a decision that's not favorable because there's confusion about it being prior work. We did mention the user agreement. That's non-negotiable. That's in one of the appendices to the FOA. Please read that. And if for some reason you feel you can't sign it, then contact NSUF as soon as possible. It's unlikely there's a workaround for that, but please ask before something fails otherwise. And then said NSUF readiness, which I mentioned I think 4 times already. It is very important. Once again, if you have questions, your technical lead can help you on that. Next slide, please. Okay, I've included this timeline here because it has some things that you won't see in the rest of the FOA. We do require a letter of intent, which is a very short communication, who you are, who you think your team is going to be, what you'd like to do, perhaps where you'd like to do it. So that's due as of these tentative dates. And please check the final FOA for the real dates. 3rd week of June. Within about 3 weeks of that, the pre-application will be due. So we will, the program office will work to get the technical lead names out to all the applicants during that time. And we strongly encourage the applicants to contact the technical leads to help them with that. Because the pre-application is due so quickly, it's a challenge to get all of that communication integration done. But even with that, pre-applications will be judged in accordance with the criteria, but the applicant won't have a lot of time to develop let's say a feasible test plan for this. And NSUF is probably a little bit more difficult otherwise. So please do reach out to your assigned technical leads. The technical leads will help you develop the preliminary statement of work. That's sort of the experiment plan. That's the project management side of it. There's a decent amount of time for that. The final statement of work is due months later. That's the one that will get attached to the user agreement, the one that both sides will basically sign on to. This is the work that we're going to do. And then, of course, the full application is due at the same time the rest of the full applications are. Next slide, please. So I mentioned our website, nsuf.inl.gov. You'll come to it. We will ask you to register, and you'll want to register, so you'll get access to the capabilities that we have. We do have a variety of resources here. We do have information on the CINR page. So perhaps the first thing to look at, give me a click, please. We'll try to walk through some of these things. There, thank you. So you can see off to the left, we've got a variety of things. If you look under solicitations, we have the rapid turnaround experience I mentioned. The CINR is the next one down. One more click, please. Thank you. So information on the CINR page will give you some contact information. Lindy Bean is our coordinator. She'll handle all the assignments. And you'll see several emails from her throughout the course of the application process. We have the dates on here. All the dates and the links currently on the page reference last year's. So once the new FOA comes out, this page will be updated. The contact information, that sort of thing, is up to date. Everything else essentially is referring to last year's. So you may want to go look at it, but a lot of it will be old. One more click, please. Thank you. So the item down one from solicitation is our NSUF resources, and we have a whole variety of databases and other tools that are available on the website. Probably the most important thing for you early on is that partner contacts. There is the fourth item down, and one final click, please. And that'll take you to this page. You can also get to this page from scrolling all the way down the NSUF main page. And this includes, you'll contact us directly, or in this case, Simon Pimblott for INL work, but this gives you the contact information for all of our different partners. And you can find their capabilities there, and you can also find it from other things on this resources tab, the explore capabilities page, and so on. The research page, the second item down, that'll take you to our previous research projects. And if you don't want to do any of this, you can go to that site search box all the way off to the left in the middle of the page, and that will search everything on the whole page, all the databases and so on. Once again, if you have any problems, please give us a call. Next slide, please. And then finally, these are our points of contacts. Dr. Chris Barr and myself. Eric Whiting is the division director for high performance computing. So one of the three of us should be able to answer your questions on NSUF access. Otherwise, that's all I have, and I've left a couple of minutes for questions.